Okay guys, let's go through like the first 4 or 5 on here just to kind of catch up and make sure we're doing this right, and then I'll leave you a few more minutes here to do the rest. Okay, so review from yesterday, okay, naming compounds. The first thing I've got to do is identify whether it's ionic or molecular. Okay, once I've identified whether it's ionic or molecular, then I follow the appropriate rules for that type of compound. So number 5, ionic or molecular. What do we think? It's molecular, yeah. Okay, it's got 2 nonmetals. Silicone is a nonmetal. It's on the right side of the staircase, and so is oxygen. Okay, so I follow those rules. Okay, there's only 1 silicone, so I don't need a prefix on that. Okay, oxygen's gonna need what prefix? Di. Okay, silicone dioxide. All right, and then for number 6, I've got carbon, okay, which is metal or nonmetal? Non-metal. And sulfur, also non-metal, so this is ionic or molecular? Molecular. Okay, so I follow those rules. Carbon doesn't need a prefix, okay, but sulfur does. Okay, tetrasulfide. Okay, questions on those 2? All right, number 7, ionic or molecular? It's a weird one. Okay. Technetium is right here. Does that make it a metal or a non-metal? It's a metal. Okay, if it starts with a metal, what kind of compound am I dealing with? Ionic. Okay, so technetium is actually very rare and man-made. Okay, so technetium iodide, okay, and iodine. I don't need a prefix in there, so it's going to be just technetium iodide. Okay, do I need a Roman numeral for that one? No. Okay, technetium does have a weird charge, however. It's a 7+. Okay, very strange. All right, for number 9, I've got Ca, which is calcium. Okay, is calcium a metal or a non-metal? It's a metal. So one of the very, well, almost very far right, okay, of the periodic table. So this is an ionic compound. Okay, and what's it with? Oh, sorry, I skipped one. I'll go back to it. What's SO4? It's sulfate, polyatomic ion. Do I have to do anything special with that? No, I just write it like it appears. All right, the one I skipped, is it similar? Yeah, and we've actually done it. It was one of the examples I gave you before. Okay, so Na is sodium, and what's OH? Hydroxide. Okay, and we also did number 10 as an example. Is that, did I tell you the story about number 10 with the potassium permanganate? Oh, I told my period 2 is this one. Okay, so K is potassium. Okay, it's a metal, right? Obviously, if there's a polyatomic ion in a compound, it's what kind of compound? Ionic. If I've got an ion in it, it has to be an ionic compound, right? Okay, so this is potassium permanganate. Okay, interesting thing about potassium permanganate. It was actually used as a fungicide. Okay, back at the end of World War II and in the Korean War. If soldiers would get fungus growing on their feet, they would put potassium permanganate solution on their feet and it would kill the fungus. The downside of potassium permanganate is it's these purple little crystals. They're quite pretty actually. Okay? But when you put it in solution, you get a dark purple solution that promptly stains your skin. Okay? Now, if you have really light skin, come on in. If you have really light skin, okay, you will notice this, okay, because it stains it a very dark brown, right? So the story I'll tell you is this one. I had this kid who never listened to me. Never listened, ever. So annoying. And this was his karma moment. Okay, we were doing a lab that involved potassium permanganate. And I had all these other things all set out. And I said, guys, make sure, remember not to handle the potassium permanganate crystals because they will stain your skin. And when I mean stain. Short of sandpaper and bleach, it's going to be weeks before this comes off. Okay? So, a little while later, Brett comes up to the front, and he's got the dish and he's playing with the crystals. Okay, with these 3 fingers. He's just playing with them, playing with them. He said, Mr. Grant, these are really pretty. They're so cool. And I just sat there and watched. Okay, and I watched him continue to play, and I watched his fingers literally turn brown over the course of like a minute. Okay, and I'm like, hey Brett, do you remember me telling you not to touch those? No. Why? Brett, look at your fingers. Now you gotta understand, Brett was like pasty white. Okay, like if he could, be an albino, he might have been. Like he was literally that light color. And then he looks at his fingers, and the tips, like right down to past the first knuckle, are dark brown. Like where have your fingers been? Dark brown. And it was funny because he, he's looking at it. He goes, well, I'll just go wash it off. He's at the sink and he's scrubbing away and whatever, and it wouldn't come off. It was weeks. Okay, that he had these dark brown fingertips. Okay, he listened a little, only a little bit better after that. Okay? But that's my funny potassium permanganate story. Don't handle potassium permanganate. Okay, it won't hurt you. It just stains your fingers darker color. All right. How many people have done number 11? Okay, let's do number 11, then I'll give you a little bit of time to do the last 4 or 5 there. Okay, so for number 11, nitrogen and oxygen, is that ionic or molecular? It's molecular, right? They're both non-metals. Okay, so do I need a prefix on nitrogen? No. All right, so I'm just going to write nitrogen. Okay, do I need a prefix on oxygen? Okay, and it's monoxide. You could also write monooxide and hyphenate it, but generally with oxygen we just go monoxide. All right, I'll give you a couple more minutes to do the last ones there, and then we will go over them and then start on going the other way. Okay, let's look at the last 4 here. Number 12, ionic or molecular? Where's Be? Where's beryllium? Beryllium a metal or a non-metal? It's a metal, okay. And this has a polyatomic ion in it, agreed? Okay, so definitely ionic on 2 fronts. Got a polyatomic ion, and it's also got a metal in it. Starts with a metal. So I name the metal beryllium. Okay, and then what's this ion? Cyanide. Okay, anyone ever heard of that stuff before? Okay. Back in ancient times, it was often known as the kingmaker. It was used to poison current kings so that their next in line could become king. Okay, cyanide was a very common poison, okay, used in ancient times. And in fact, still can be used if you watch any like spy movies. They have like the cyanide tooth that they can just bite down on, and then it'll kill them in short order. Okay, cyanide interferes with how your cells make energy and burn sugar. When it gets into your cells, it simply blocks the pathway that completes cellular respiration. So you just get really tired and die, okay, because your body isn't burning sugar and making energy anymore, right? You can tell, not that you'll ever need to know this, but if you've ingested it, it tastes like bitter almonds. Okay, so if you've ever eaten almonds, imagine almonds but bitter. Okay, that's what cyanide typically tastes like. Okay? So if you ever eat a bunch of things and then it tastes like bitter almonds, you better get that back up in a hurry. Okay? All right, and then this stuff here wouldn't be beryllium cyanide, it would be, what's Ba? Barium. This would be barium cyanide. Okay, number 14. Ionic or molecular? It's ionic. Sodium is a metal, okay? Very metal. All right, and what's HCO3? Hydrogen carbonate. It's also sometimes called bicarbonate. Okay? So sodium, hydrogen carbonate. What's the common name for this stuff? We use it quite commonly, actually. Sodium bicarbonate or sodium hydrogen carbonate.
baking soda?
It's baking soda. Yeah, that's what baking soda is chemically. All right, and last one, ionic or molecular? It's molecular, okay? The reason I put this on here is it also looks like one of your polyatomic ions, okay? But it's not a polyatomic ion unless it's with something else, okay? If it's by itself, then it's a molecular compound. There are some cases where that can happen, okay? This would be one of them. So this stuff here would be phosphorus, because it's molecular, okay? Tetra oxide. Okay, I'm going to give you one last one here because we haven't dealt with this one, and it can be tricky. So why is this one tricky? Does it have 3 nonmetals in it? Okay, do we know how to name a compound that's molecular that has 3 nonmetals in it? You know why we don't know how to do that? Because it's not molecular. NH4 is the only metallic polyatomic ion on your chart. Okay? Right here near the top. But it's the only one on the chart that's positively charged. And if it's positively charged, it behaves like a metal. But it's tricky because it starts with a nonmetal. And so when you see it written out like this, you're like, oh, it's molecular because it starts with a nonmetal. Except it doesn't. Well, I mean, it does, but it's a polyatomic ion, okay? And so that's why it can be tricky. This stuff I would actually name as an ionic compound because it is. So it's one to watch out for, okay? This stuff would be ammonium chloride. Okay? And ammonium can actually bond with other polyatomic ions, okay? It can do this. Okay, that would be ammonium nitrate. You have also probably had experience with this stuff. If you've ever used one of those cold packs where you pop the little water bladder inside with your fingers and shake it up and it gets cold, okay, the little crystals that are inside of there are ammonium nitrate. When they dissolve in water, they get really cold. Okay, that's commercial use for that stuff. All right, questions on the naming part? Okay, because now we got to look at, I give you the name, now you write the formula. Okay, this is where you're going to use the drop and swap. You're familiar with that. Okay, that's not going to change. We're just going to have to use it now with some normal ionic compounds that you'd have had experience with already, as well as some ionic compounds that have polyatomic ions. This is where brackets are going to come into place. Okay, and then we're going to look also at molecular compounds, which are pretty easy. You just go by the prefixes to give you the numbers. All right. Okay, so if I want to convert chemical names into formulas, just like when I was doing naming, I have to identify whether it's ionic or molecular because the rules are different. Okay? If I have an ionic compound, because it starts with a metal or ammonium, okay, I simply write the formula for the metal along with its charge. Where do I get its charge from? How do I know the charge of the metal? Does it tell me that somewhere? I see you pointing at it. Top right corner of every box on your periodic table. Okay? Top right corner here, this is the charge, this is the charge, this is the charge, that's the charge. You can always look up the charge on the periodic table. Okay, for your nonmetals, you have to remember what charge goes with what group. Okay, so group 18 are the noble gases, no charge. Group 17, okay, they're the halogens, they are -1. Okay, next group over, those are -2. Next group over, those are -3. Okay, so 17, that's a -1. Okay, 16, that's a -2. 15, that's a -3. You can just count how many rows over they are from the noble gases. That number equates to their charge. Okay? All right, so we write the name of the metal, indicate its charge, write the formula for the non-metal, indicate its charge, and then drop and swap. Simple as that. Okay, that's all there is to it. All right, so let's say I give you this one here. Okay, so we'll walk through this one as an example. All right, so is that ionic or molecular? It's ionic. Rubidium is in group 1. Okay, right here. All right, so next step, since I've identified it as ionic, okay, is I write the formula for rubidium. So I go capital R little b, and I write its charge, +1. Sulfide, S. Sulfur is a -2. Okay, and then I just drop and swap those numbers. Whether they're positive or negative no longer matters. Okay, the 2 goes here, the 1 goes there, but we don't write 1s. We're done. Rb2S. Okay. Is that pretty straightforward? All right. Are there a few places you need to be careful? What if I gave you this one? Okay, this one has 2 little tricks in it. All right, so is this ionic or molecular? It's ionic, okay? If you see a Roman numeral, it's ionic, okay? Lead, Pb. What's the charge on lead in this case? 4. That's what the Roman numeral is there for. It helps me with the drop and swap. Okay, I see the Roman numeral 4. This is the lead that is +4. Okay, and it goes with oxygen. Oh, oxygen's always a -2. Okay, now, herein lies my problem. When I drop and swap, I get a 2 here and a 4 here. Can I leave it like that? What do I have to do with those numbers? If I gave you this, 2/4, what would you do with it? Would you reduce it? You have to do the same thing with ionic compounds. Okay? This is not the way lead and oxygen go together. Okay? They go together in whole number ratios, but the part of that third point of the atomic theory where it says whole number ratios, it doesn't say this, but it's true. Simplest whole number ratio. Okay? So you have to simplify it down if you can. This is a really easy multiple choice question for me to make on a unit exam. Okay? I ask you, what's the formula for lead 4 oxide? And I do this, Pb2O4. Okay? PbO. Okay? PbO2. And, I don't know, maybe just throw in a fourth one here. Pb4O. Okay? I get some people to pick that because of the Roman numeral. Okay? Is that a pretty easy multiple choice question for me to make up? I will do that, by the way. Spoiler alert. Okay? This tests, do you remember that little rule about reducing your numbers down? The correct formula for lead 4 oxide is PbO2. Okay? Both of those numbers could be divided by 2, thus both of those numbers must be divided by 2. Okay? Would the same thing apply if I got the same number? Like what if I had okay, would I write Ca2S2? No. this is already balanced, right? I got a +2 and a -2. I only need one of each. And those are balanced out and happy. Okay, so know that you do need to always make your ionic compounds in their lowest terms after you drop and swap. Okay, another place where there can be a little bit of an issue, what if I gave you this one? No, sorry, that's wrong. Okay, so obviously this one's also ionic. Magnesium is a metal. Okay, I'll give you a minute to see a bunch of you trying it. I'll give you a minute to try it here, and then we'll go through it. Okay, so if I'm following the rules here, I go magnesium, 2+, and nitrate, NO3, -1. All right? When I drop and swap, I think I used this one as the example when I showed you this before, okay? I bring the 2 and I put it here. I bring the 1, I put it there, but we don't write ones. Can I leave it like this? Because that means 1 nitrogen and 32 oxygens. This is supposed to say 1 magnesium and 2 nitrate ions. Okay, so with polyatomic ions, if you've got to put a number beside them, you have to enclose them in brackets. Okay? That's a common one for people to make a mistake. Okay, those are all the tricks. Okay, I gave you one with a Roman numeral. Okay, the Roman numeral tells you what charge to use. And I gave you one with a polyatomic ion. Okay, that requires you to put brackets around it. That's it. Those are the only tricks. Okay. Okay, if I have a molecular compounds are really easy. Write each one's symbol and then use the prefixes to tell you how many of each there are. Okay, that's all there is to it. If it says dinitrogen trioxide, it's N2O3. Okay, you just have to use the prefixes. Now, one catch. If I have this one, do I reduce that? If I had tetraphosphorus decaoxide? I don't. Remember, in molecular compounds, we're not trying to balance charges. Okay? If we're balancing charges, then we have to reduce because that's the way it would go. In a molecular compound, they're sharing them. If the name says tetraphosphorus, it means there are 4 phosphorus. If it says decaoxide, it means there are 10 oxygen atoms. Okay? We never reduce molecular compounds because the prefixes have told us there's this many of each one. Okay? Everybody all right with that? Okay. Okay, so the shortcut of what you have in your notes there is this. Okay, ionic, write the name of the metal. Okay, write the name of the non-metal, ends in "ide." Okay, that's for the naming. Okay, and then if it's polyatomic, write it as it appears. Okay, so that's just the shortcut. Okay, for writing formulas. Did anyone want to just take a picture of those? I kind of skipped over those quickly, but you kind of have it written in your notes already. Okay, anybody want to? Okay. And guys, you can totally do that. Okay, anything that goes on the smartboard, if you want to take your phone out and snap a picture of what's on the smartboard, you go right ahead. Okay, a lot of people do that, and then you just throw it in the notes package after. Come on. All right, so our first one here, we've got calcium phosphide, ionic or molecular? Ionic, calcium is a metal. Okay, so I'm going to write calcium and its charge, 2+, okay, and phosphorus and its charge, -3, and then I'm just going to drop and swap. 3 goes here, 2 goes here, Ca3, D2. Okay. For cesium oxide, so we'll have Cs, Is this ionic or molecular? It's ionic. Cesium is a metal as well. Okay, and it's a +1, right? And it is with oxygen, which is a -2. Drop and swap. 1 goes there. We don't write 1s. CS2O. All right, number 3, first one that's got a Roman numeral. What does the Roman numeral tell me again? It tells me the charge to use in the drop and swap. All right, so I'm going to have manganese, which is Mn, and the Roman numeral tells me this is the +4 kind. All right, and it is with oxygen, okay, which is a -2. All right, when I drop and swap this one, what am I going to have to do with the numbers? Reduce them. I'm going to get 2 and 4 here, right? Okay, can see that already. And if I drop and swap, I got Mn2O4, okay, which I then have to reduce to 1 and 2. So we should have MnO2 for that. I guarantee you there'll be one like that on your quiz tomorrow. Okay. All right, and then for number 4, another one with a Roman numeral. If it's got a Roman numeral, is it ionic? Yes, every time. Okay. All right, so we got iron, Roman numeral 2. So we write the symbol for iron. The Roman numeral tells me this is the 2+ kind of iron. Okay, and it is with sulfide, S, which is a -2. All right, do +2 and -2 already add up to 0? Okay, am I good then? Yeah, I don't need to write any numbers. If I did, I'd have to reduce them down to 1 and 1 anyway. FES for that one. All right, and then the last one, my favorite thing, okay, that has my funny story. Okay, potassium permanganate. All right, ionic compound, K is a +1, and it's with permanganate, MnO4, which is a -1. And when I drop and swap, these are already adding up to 0, yes? K, MnO4. Now, would it be wrong, even though I don't technically need them, would it be wrong if I did that? It's not wrong. It's not necessary, but it's not wrong. Okay? We just generally don't put brackets in unless we have to put a number outside of them. Okay. Give you a few more minutes here. Okay, let's say go to number 12 for now. Okay, and then we'll see how we're doing. All right, so looking at number 6, we got silver chloride, ionic or molecular? Is silver a metal? It is. Okay, so Ag, okay, silver has a +1 charge, and it is with chlorine, which is a -1. Do I need to do anything else? 1 and 1, right? Okay, so we're done. AgCl is our formula there. Okay, number 7, copper 2 hydroxide. All right, what does the Roman numeral tell me? That it's ionic, and it tells me what about copper?
+2.
That it's a +2. Okay, so we got the 2+ kind of copper, and it is with hydroxide, a polyatomic ion with a charge of -1. All right, what am I going to need here? When I drop and swap this, the 1 will go here and the 2 will go here. Do I want to leave it like that? I need brackets, okay? Otherwise, I'm saying there's 1 copper, 1 oxygen, and 2 hydrogens. This set, I've got copper and hydroxide. That means the hydroxide needs to be enclosed, okay, in brackets. Okay, number 8's got that tricky one. Ammonium sulfide, right? The only positively charged metallic polyatomic ion. Right, so NH4 with the +1 charge. So we're definitely dealing with an ionic compound, and it is with sulfur, which is a -2. All right, so when I drop and swap, what am I going to need? I'm going to need brackets again. Okay, this 1, okay, the 1 from ammonium is going to go down here, but I don't write 1s. The 2 is going to go here. I don't want to say NH42S. Okay, I want to say NH42S. Okay, that is ammonium sulfide. Okay, everybody following the use of the brackets? Okay, it's tricky, we gotta remember it. If you got a polyatomic ion, you are likely going to need brackets. Okay? Or you can just always enclose them in brackets. And then if you don't need a number, we already said it's not wrong to have brackets without a number. Okay, so it's totally up to you. If you want to, every time you see a polyatomic ion, put it in brackets, that's totally fine too. Okay. All right, nickel 2 bromide. All right, so nickel is Ni, and it's 2 plus, okay, and it is with bromine, which is a -1. So when I drop and swap, the 1's going to go here, and the 2 is going to go there, and I'm good. I don't need brackets because I don't have any polyatomic ions. All right, and then for iron 2 oxide, okay, we've got an ionic compound because iron is obviously a metal, and the 2 tells me it's the 2 plus kind, and it's with oxygen, which is a -2. Am I already good? If the things you have written up top add up to 0, that is, they're the same number, okay, then you don't have to drop and swap. All right, number 11, we got mercury 1 sulfate. So that's Hg plus 1 with sulfate, SO4, which is a -2. So when I drop and swap, the 1 will go here. We don't write 1s. The 2 will go here. Hg2SO4. Okay? And if you wanted to, it would not be wrong, but it is unnecessary to do that. Okay. All right, last one I said to do, okay, is iron 3 oxide. All right, so we would have Fe with the 3 plus, oxygen with the 2 minus. Okay, when we drop and swap, Fe2O3. Okay, did you have any molecular ones in that 12, in that dozen questions? Not a single one. Okay, here's why. They're really easy. Okay, you just look at the prefixes and you're finished. Okay, so I make you do the ionic ones more because there's more opportunity, okay, to make mistakes, so we need more practice on those. Okay, now, in your digital workbook, there are like 5 or 6 naming and formula worksheets. I have no intention to do them all in class. Okay, but a way to get good at this is to practice. Okay, here's the other thing you have. In Google Classroom, in the same place where you can find, okay, this, you will also find under course materials all the worksheet keys for chemistry. Okay, so if you click on that, okay, there's reactions ones, you don't need those, but here's all the naming ones. Okay, naming key 1, naming key 2, okay, 3, 4, and 5. All right, so you can always do some and then check your answers. Okay, when you're doing that, or if you're doing that, here's my advice to you. Do 4 or 5 and then check the answers. Okay, because if you're making a mistake, you want to find out right away. Right? There's nothing worse than doing a whole worksheet and then realize all you've done is practice a bad habit for 50 questions. Okay, because it's going to be really hard to break that habit if that's the case. Okay, so I wouldn't do more than 5 without checking the key to make sure you're getting them right. Okay, if you're doing that and you're struggling with it, that's when you need to come in and see me. Okay, it's probably something simple and we'll get it figured out. Okay, help times are on the board. I have no life, I'm always here. Okay, so you can come and see me. The only reason I wouldn't be in here at lunch would be that I'm on supervision outside. Okay, so that's why we've got, okay, I'm here in the mornings, okay, except Tuesdays when we have our staff meeting. Okay, first half of lunch on Monday and Tuesday. Okay, second half of lunch on Wednesday and Thursdays. Okay, and after school, Monday, Wednesday, and Thursday. Okay, so you can always pop in and see me. Sometimes I'm even here on Tuesday after school. Okay, fair enough? All right, I'm going to give you a 5-minute break. You can answer all those burning snaps that need to be answered. Okay, all your friends who are anxious for a reply from you. Okay, so take 5 minutes. Okay, a little break within the classroom here, and now we're going to do some more of these. So try the ones that are circled. Okay, there's a mix there. There's finally a few molecular ones in there as well. Okay, give you a few minutes on those, and we'll go through them together. Kind of my intention today was to really do a lot of practice, okay, and then see how we're doing tomorrow on the quiz. Okay, if we're doing well on that, then we're going to move on. Okay, start talking about scientific method and lab reports and things of that nature. All right, so our first one there, magnesium phosphide, ionic or molecular? What do we think? It's ionic. Magnesium is a metal. Okay, so we follow our ionic rules. Okay, we write the formula for magnesium, and its charge 2+. It's with phosphorus, that's P, and it's a -3 Mg3P2. Okay, that would be our formula for that one. All right, number 15, diphosphorus pentaoxide. As soon as I see prefixes, I know it's molecular. All right, and that makes it easy. Phosphorus is P, di is 2, oxide is O, penta is 5, P2O5. Okay, so we don't really have to think too much with those. All right, we just have to read the prefixes and put the appropriate number in. Okay, number 16 might be a little bit tricky. We got aluminum phosphate, ionic or molecular? Ionic, aluminum is a metal. Okay, and aluminum has a +3 charge. Phosphate is a polyatomic ion, PO4. I believe it's -3, right? Phosphate. 3-, yeah. Okay. Do those already balance? They do. That's my formula. AlPO4. You could enclose the PO4 in brackets if you wanted, but it's not necessary. Okay, copper 2 nitrate, ionic or molecular? Ionic. It's ionic. Copper is a metal. And the Roman numeral tells me this is the copper with the 2+ charge. All right, so we got 2+. Okay, nitrate is NO3. That's a -1, so when we drop and swap, the 1 goes there. Okay, the 2 goes here, and because I wrote a number beside the polyatomic ion, it has to be enclosed in brackets. Okay? All right, and number 18, ionic or molecular? Molecular. It's 2 nonmetals, and there's a prefix in there. Okay, nitrogen dioxide. Nitrogen is N. There was no prefix on the N, so it's a 1. Okay, dioxide, oxygen, with a 2 beside it, NO2. Okay, if you got questions as we're going along, guys, don't be afraid to ask. Okay, phosphorus trichloride, ionic or molecular? Molecular. We've got a prefix in it. It's 2 nonmetals. Okay, phosphorus had no prefix, so it's a 1. Okay, trichloride, Cl with a 3 beside it. Okay, and potassium carbonate, ionic or molecular? Ionic. Potassium is a metal. Okay, so K +1. Carbonate. What's that? Polyatomic ion. Okay, CO3, and its charge is -2. Right, so the 2's got to go there, the 1's got to go there. I could enclose that in brackets if I wanted, but it's not necessary. Okay? Now, the thing I'm going to caution you about here is that like, you're going to get to the point where you're going to be able to do what I'm doing. I just know these and I know their charges because I do it all the time. But every once in a while, I get one wrong. Like I went and checked what the charge on phosphate was because I wasn't sure it was 3. I was pretty sure. Okay? Should you always check? Absolutely, you should always check. Okay, that's why you're allowed to have your periodic table in front of you on quizzes, on tests, on your diploma exam. If you take Chem 30, you get a data booklet that includes that periodic table. Okay, along with a bunch of other like numbers and constants and formulas and all of that stuff. We don't expect you to memorize it. Okay, you're going to get pretty familiar with it. You're going to have a lot of them memorized, but the reason we let you have that is so that you can always double check. Okay, and you should always double check. All right, so we just did potassium carbonate. Whoa, that's not what I wanted. Come Sorry guys, my computer has to think too hard for this. Okay, lost my